Every single day, you and I leave behind a massive, messy trail of digital footprints. I mean, think about it. Every click, every swipe, even just pausing on a screen, it all creates this vast, noisy ocean of data about human behavior. But here's the catch. If we get the interpretation of that data wrong, we risk building systems that completely misunderstand, misguide, or worse, manipulate us. It's a massive challenge, and the stakes literally couldn't be higher for businesses, policymakers, and researchers. So, welcome to this explainer on Chapter 3 of the Cambridge Handbook of Behavioural Data Science. Today, we're diving straight into the framework and topology of methods we actually need to rigorously understand human action in our wild digital world. So how do we actually extract human meaning from billions of messy digital traces? For decades, traditional behavioral science relied on highly controlled small-scale stuff, lab experiments or surveys. If you wanted to know why people did something, you just ask them or put them in a lab. But today, the landscape has entirely changed. The central problem we're facing now is dealing with massive, high-velocity, and incredibly ambiguous digital data streams. Because a location ping or a delayed login doesn't just speak for itself, right? It's a passive, noisy trace. So the million-dollar question is, how do we pull true human meaning from all these messy digital byproducts? Well, the main argument of the chapter is brilliantly captured by this idea. In plain English, you absolutely cannot just throw raw digital data into a machine learning algorithm and expect meaningful behavioral insights. It just doesn't work that way. To truly make sense of modern data, we have to embrace a hybrid methodological approach. We need the deep, nuanced contextual understanding of traditional behavioral theory, and we have to combine that with the raw processing power of modern computational data science. You really need both. Otherwise, you're setting yourself up for some catastrophic inferential errors. To map out this intellectual journey, here's our roadmap. 1. The Behavioral Data Challenge. 2. 4 Pillars of Methodology. 3. Ethics, AI, and Tensions. And 4. Lessons for the Future. Let's get right into it.
Section 1. The Behavioral Data Challenge. The text breaks down a really crucial 4-stage methodological pipeline. It starts with data collection, so that's both active surveys and passive digital observation. Then comes data processing, where we clean and harmonize things. But actually, the chapter highlights something super important here. Processing isn't just a technical step, it's an interpretive one. Deciding what to do with a missing data point is a theoretical choice. Does it mean a system error, or is the user deliberately disengaging? Then we move to feature engineering, translating raw data into variables, and finally, model development, where we build out our predictive or inferential systems.
The shift happening at the feature engineering stage is huge. Look at classical science. If you wanted to measure a construct like impulsivity, you'd use a validated questionnaire. Pretty straightforward. But in behavioral data science, we just don't have that luxury. Instead, we have to infer latent behaviors. Take procrastination in online learning as an example. We might construct a feature by cobbling together erratic login times, periods of inactivity, and last-minute submission timestamps. We're carefully translating these complex digital traces into structured, theoretically sound behavioral variables. Moving on to Section 2, 4 Pillars of Methodology.
The text introduces a topology organized around 4 foundational pillars. First up is hypothesis testing at scale, which basically uses digital infrastructure to run massive classical experiments. Second is data science modeling for behavioral problems. That's pointing traditional machine learning tools at behavioral datasets to hunt for patterns. Third is gap detection, which is an approach entirely focused on finding the blind spots, errors, and biases in algorithmic systems. And fourth, we have hybrid modeling.
Now, this 4th pillar, hybrid modeling, is a huge deal. Honestly, it solves a massive headache in the field. See, pure machine learning, like deep neural networks, is incredibly powerful at prediction, but is essentially an opaque black box. Pure behavioral theory, on the flip side, is highly interpretable but completely struggles to scale across billions of messy data points. Hybrid modeling harmonizes the two. It enriches the interpretable decision-theoretic models of human behavior with the predictive flexibility and scale of modern machine learning. It gives us systems that are both highly accurate and, crucially, actually intelligible to us humans. What's really fascinating here is how these 4 pillars map onto a philosophical grid of ontology, what we believe reality actually is, and epistemology, how we believe we can build knowledge. For instance, hypothesis testing at scale assumes an objective reality we can measure precisely, but on the flip side, gap detection is much more focused on how data is socially constructed and embedded with human biases. This proves that behavioral data science isn't just a single, monolithic thing. It's a rich, pluralistic field where multiple ways of knowing coexist. All right, Section 3, Ethics, AI, and Tensions. But how does this theoretical stuff connect to the real world? The text provides some striking concrete examples. In education, systems can predict student procrastination just by tracking inactivity periods, which allows for early interventions. In mental health, models are attempting to infer depression markers simply from how someone types or swipes on their smartphone, which is incredible, but frankly, kind of unsettling too. And in commerce, micro-targeting uses online traces to create opaque behavioral segments. These examples highlight the immense power of behavioral data science to create personalized interventions, but they absolutely raise some massive red flags as well.
We really have to confront these methodological and ethical tensions head-on. Because algorithms learn from historical data, they often encode deeply entrenched structural inequalities. If a model sacrifices explainability for raw performance, it just becomes a dangerous black box. We risk applying stigmatizing, completely inaccurate labels to people's mental health. We risk triggering educational interventions that are totally blind to a student's context. And, perhaps most concerning of all, we risk eroding human autonomy through invisible, opaque micro-targeting that manipulates our choices without us even realizing it.
Finally, Section 4, Lessons for the Future. So what are the key lessons for practitioners here? The crucial takeaway is that mere regulatory compliance is simply not enough. Practitioners must commit to ethical reflexivity. This means actively questioning the assumptions embedded in your data at every single stage of that pipeline we discussed earlier. Leaders need to mandate transparent model documentation. They have to use participatory design, actively involving the people whose behavior is actually being modeled. And they must conduct regular, rigorous impact audits to ensure interventions are genuinely helping, rather than silently causing harm. Ultimately, the most profound contribution of this chapter is its call for epistemic pluralism. The future of this field won't be won by dogmatically sticking to just one method. Researchers and AI practitioners must move flexibly across paradigms. Sometimes you absolutely need the pure predictive power of a neural network. Other times, you need the rigid control of an A/B test. And sometimes, you need to halt the whole process to audit for bias using gap detection. Balancing interpretability, prediction, and ethical reflexivity is the true hallmark of behavioral data science. And that brings us to the frontier. With the rapid rise of generative AI, we're seeing systems that don't just model human behavior, but actively mimic it. As that line blurs, how will we ensure our systems remain not just intelligent, but intelligible and accountable to the humans they actually serve? I'm going to leave you with that open question to ponder as you dive into the full text of Chapter 3 in the Cambridge Handbook of Behavioral Data Science. It's an absolute must-read for anyone serious about the future of AI and human behavior. Thanks for joining me on this explainer, and keep questioning the data.